Today, my talk will be about causal NLP, the synergies between NLP and causal inference community. So a lot of ideas of this talk is inspired between discussions with Farhan. So I also highly acknowledge him and think he's great. The main mind behind the discussions we will have today. And then, great, let's let it reload. And also, some of the slides are updated with the content of the ongoing conference and workshop. So first, some background. I started my causal NLP journey mainly from an NLP background, and then since before PhD. And since I started my PhD, causal NLP is a theme. And the goal of my synergy talk today is to induce a causal effect. Where before, maybe causality and NLP sound like two distinct areas, and afterwards, also maybe the combined effect of mine and Atticus' talk, afterwards, we'll bring more attention to the very high potential of the synergy. It could come from, for example, causality is a great tool to solve NLP problems or understand LLMs, or NLP models need to be causal. And then we together build a bigger and more impactful community at the intersection. So I start from what do we need and what we can provide. So I have two views from people from the two different backgrounds, causality background and NLP background. From the causality background, for example, if our background is causal representation learning, a simple extension could be to understand how can models, for example, LLMs, understand the causal model of the world better. If the background is more causal inference, the synergy could be that the tools like causal discovery and effect estimation could also be applied to understand LLMs to decode the mechanism of a phenomenon, and that can be biological reaction to a drug, or it could be LLM's reaction. And how does the synergy work? So people from the NLP side usually care about several major problems, such as, can we make more capable models? Which is a direct connection to, does the model, there are some strong synergy with causal representation learning. And the other need is, can we deploy AI assistance for actual real-world tasks? If we ever want to deploy LLM, then a great need will be we know how to debug what's happening in LLM. For example, for the Bing assistant recently, how to debug and get rid of the I am Sydney weird thing from it. Or we should learn, when we apply LLM for certain scenarios, what scenario can we trust? Also, echoing with Atticus' talk, what type of ability can we more formally believe for LLMs, and what are some illusions? So I'll lead the talk through a bunch of questions. Given the audience, I actually put extra effort into explaining why do we need to care about causal NLP, starting from a causality background. So I usually imagine us as a little part of an ecosystem. It could be environmental ecosystem. It could also be our research ecosystem. The research we are provided the opportunity to do is usually a tip of an iceberg, supported by who currently support it. And then we know that this iceberg is very huge, but maybe at the tip of the iceberg, in the long run, we will see whether this iceberg can go stronger, whether our research can be supported by more parties or more robustly, or where it's start to a little bit fade. So now I brainstorm the causes of the ice ice. Absolutely, there will be constant support for a fundamental science, given the condition that the world is peaceful and economic is strong to support it. Or having some more applications will actually drive more people to pay attention to it, and then we get much more support structure. What I want to say is that by motivation, LLMs could inspire both parts, in that if we extend a CRL series for LLMs, then we get more interesting scientific insights. If we also work on safer, like make LLMs more interpretable, robust, then we also boost the application, which means better ecosystem around our research. Then, given this, what is the problem space of NLP that we can dive into? Especially, I just set aside, given the current Twitter environment, where we see so many different tweets about now we develop this, now we develop that. Like among this dazzling environment, how can we find a pivot view? So I started my pivot view as technologies might be, or whatever Twitter posts and new papers can be changing, but humans' fundamental needs are more stable, change relatively less. So it's the causal structure is more OOD robust. And then humans need, this is a very rudimentary classification. We have a lot of daily life needs. We want to boost our efficiency for workspace. That's why Microsoft is heavily deploying LLMs into their Office or Bing and stuff. And we also have domestic and international issues that we want to draw more insights for. With the role of LLMs, how could it satisfy these needs? There are two types of causal links to causality that will be helpful. The first problem formulation is, what if we want an AI assistant? I'm here to answer all why questions. Or another type of assistant, I'm here to help you solve tasks. But like maybe the hidden guarantee or our preference would be the ideal assistant should solve them with the correct causal knowledge so that it's correct solution and efficient solution. So I summarize these two need into answer why questions and do tasks correctly, and they help different social issues. Then what is the potential of adding causality into it, the causal NLP? So I identify further two sub-questions. So in order for the goal of answer why questions better, then the remaining space will be, okay, GPT-4 now answers a lot of questions nicely. What further, either daily life or social issue related why questions is challenging for it. And we must add in the intelligence of causality into it. Or for doing the tasks correctly, how can we ensure its robustness? It includes the two threads of our work. One is large-scale test for invariance from the outside, like designing many substitution and then adversarial attack for NLP. Or treat model behavior as the subject of causality, linking to the previous talk. So for the first question, we'll first look into some effort that we're putting into addressing it. So especially my hypothesis here is that causal and logical reasoning will stay highly challenging for GPT. And then moreover, if some of the causal reasoning involves a combination of model principles, it becomes even more challenging. So one example is if you imagine you ask a future model, like we think about the ideal model. If you want to ask a future model, when is it okay to tell a white lie? Or when is it okay to let a person cut the line? So it's a question about to do or not to do. To answer this question nicely, it becomes like we need a combination of causal and moral reasoning, in that the causal reasoning is about turning the switch or not turning the switch, what outcome will not doing it lead to, maybe A and B will happen. And then what outcome will doing it lead to, maybe B and C will happen. And then after this, so the first step becomes a causal step. But so my roadmap forward is that in order to answer this type of question, the first step is to use causality to map an action to an outcome. Then in terms of two different set of outcomes, it could be like comparing apples to bananas. But in a lot of cases, humans have to make a decision. Then it's some moral principles that lead us to score the outcome or say that A is strictly permitted, strictly prohibited in our society. So we definitely wouldn't do the first pass, and so on. And together we address a very frequent set of questions to LLMs. Should I do this or not? Or why should I do it? And this type of question is not very far away. It could be behind people's reasoning about whether they should vote for Brexit or not, or whether they are against universal healthcare, which is the case of the US. And the synergy here is that the causal part will definitely need some strong reasoning ability that is out of the scope of the current GPT. And then one example, also inspired by our lab's COVID paper, I was thinking about the universal healthcare case. There could also be a Simpson's paradox. This is a composed example, but just to use to illustrate the idea. For example, if a US voter decided to not vote for universal healthcare, saying that US has no universal healthcare so far, Italy has it, we see US economy much stronger, so universal healthcare is bad. We don't want that. So this is a typical reasoning that has a bunch of correct facts, but the wrong reasoning. And if malicious parties trick LMs largely, strongly enough, it could be easy to induce causally fallacious reasoning affected by propaganda and stuff, or people with interest in arguing for that, and then lead our society to make a different decision from what's the best one. And then, so with all these motivation, how we design our actual project is that we look into the reasoning ability, the why, answering the why question ability from two axes. One is the problem of knowledge, and the other is the problem of reasoning. For the problem of knowledge, it's mainly the question that can be solved by Wikipedia, WikiHow, Quora, and stuff. For example, when I ask GPT, why do we have to reduce CO2 emission? It answers it in a causal manner. It says it will, because excessive CO2 contribute to climate change. Climate change causes global warming, severe weather events, and rising sea levels, and so on. We could say that, it answers why questions. But then I think what the causality community need to focus on is the things that are not heavily knowledge, but heavily reasoning. It could be one like the Simpson's paradox example. It could also be an example whiting against propaganda. For example, when I ask large language model Putin's motivation behind ongoing war, it's largely whitewashing Putin, saying that he wants to make Russia a stronger place and Ukraine tend to be where Russians live, and so on. So we even face this question that is anti-knowledge, because it's anti what's common on the internet by propaganda machine, and we rely on causal understanding of the world. That specific case is a collider bias, because fact and political goal causes media. And so there could be some even higher level causal framework we could apply to GPT. So with all these motivation, I'll quickly go through. We're now working on a causal benchmark data set composing of 10K reasoning intensive causal questions. And we vary across run 2, run 3 questions and paired with many different causal graphs. So ongoing work, stay tuned. And for example, one example of the data set is that we swap the firing squad case to CEO tell manager 1, manager 2, and then they lead to firing the employee or not, and ask GPT about this. So this is the first part, and the second thread is how can we ensure the robustness of LLMs? For the second thread, for example, one of our papers, I think similar to the spirit of editor's talk, we also look at how to understand whether LLMs can robustly handle certain problems. And we take as an example simple math word problems, such as Mark has N1 trees in his backyard. If he plants N2 more, how many trees does he have? So it's a simple arithmetic problem, 12 plus 13 equals 25. And then to look into that, we define the robustness score as the difference between the correct SCM and the learned SCM. Let's say the correct one takes in N1, N2, do the calculation and output the sentence. However, some incorrect one might take some spurious correlation, such as whether it's Mark or not, whether it's trees or apples. So there could be some other spurious information that the model take into account. So we use in red to highlight the difference between SCMs. And then basically we develop a framework to actually provide a score to say the behavior difference across like from an ideal SEM to the SEM, like the actual behavior we're seeing on LLMs. So the key insight is that instead of using the word spurious correlations, we actually frame it as it's the elements that caused the model decision, but should not have been doing that. So it doesn't exist in the correct SEM, but it exists in the current model learned SEM. So another type of thing we look into is more understanding of what causes model performance. This is a follow-up of our first year's work on causal and anti-causal learning for NLP. Further, we look into what affects a machine translation system, just as a case study. So translation effect is the thing that when you translate language one to, like say, German to English, the corpus is slightly different from the English to German corpus, where I use H as the human translation direction. There are certain linguistic phenomena that's happening, but in general, our framework is to say that when a paper reports the MT, like the machine translation performance, there are multiple causes of it. One cause is the real translation quality. Some other causes are, for example, whether the data and the model are matching. So that's the case of causal and anti-causal learning, or some other facts. So we look into it in a more causal way. What does it mean? Mainly because if we want to see the data model direction match, then it has an open backdoor path actually, because let's say the Germany originated language might talk more about EU or national politics, while the English native language might talk about either UK or the US more. So we have to control for the content, and also German tend to be longer than English. So we also have to control for the sentence length. So this is just a framework where we use NLP to match the content by the embedding of the text and match the sentence length just by the number of words. And then we actually control for the two, cut the backdoor path, and inspect the effect, how causal learning boosts the MT performance. So we causally derived the conclusion and see a 3-point or 5-point performance boosting if it's causal training rather than anti-causal training. So that's just an example for making models as the subject of causal effect estimation. Yeah, I'll very quickly go through. A final bonus point is text can also serve as a variable for causal effect estimation. And that can solve for this path where we want to tackle some domestic and international issues, and we want to answer a why question. And it's impossible for GPT to answer this question correctly. One example we have is how can GPT answer why does the governor decide a certain COVID policy, or whether there exists a gender bias or not, given the data you want to plug it in, or can censorship backfire? It's too hard for GPT to answer, and it's even a science question. So what we do is we have different type of framework. One type of framework, we investigate the how policies are made, what affects policies in the COVID time. So what we do is that we map the natural language in tweets into a sentiment from -1 to 1 and control for the confounders such as COVID cases or high or low. And then we see the effect as a social distancing policy, whether a state is highly locked down or opens up. And we get some causal effect on this by controlling for the backdoor path. So that's one type of paradigm. We're also working on another type of paradigm where NLP can embed text. So whenever in causal effect estimation, we want to control for some variable, and what if the variable is paper text, such as given the same paper, do women and men tend to write differently? Then we have to control for the text variable as the content. So the quick takeaway is that it's encoded in text embeddings, and then we can just adjust for this high dimensional embedding. So more to come, and we also curate a paper list of causality for NLP papers, updated with time. And in summary, our talk went through why does this audience need to care about causal NLP? what is the problem space of NLP, what is the potential of these two joining together, causal NLP, and how do we address like our lab's ongoing efforts. And we open a lot more future opportunities. So I also want to thank all the collaborators and the great minds that make these papers into possibility. And they're open for discussion and collaborations. One example concrete step is if you have spot any functions of the LLM that currently has a bug, and this bug can be greatly helped by causality, feel free to get in touch. Great, thank you.